So in 9.2 and 9.3, we are going to do arithmetic sequences and geometric. It is pronounced arithmetic, even though it looks like arithmetic because it's an adjective. It sounds different. I don't know. I didn't make up the English language. That's just how it goes. So if you're wondering why I'm saying that. But these are two different types of sequences. We've actually already done one of each. We just haven't named it by the name. An arithmetic sequence is a sequence that increases by the same amount each time. So you're either adding the same number or you're subtracting the same number each time. So that's arithmetic. You're going to add or subtract the same number each time. And that number that you add or subtract, we call that the common difference. And the variable we use for that, for common difference, is a d. So I'm going to show you guys how we would write the recursive formula and also how we would write the explicit formula for an arithmetic sequence. And these, once you know the specific things in it, it's not as hard as last time's trying to find the explicit formula. So we'll start with recursive first. So for the recursive formula, that's the one that has two parts, right? You always have to put the first term. So we'll do the first term. And then we do the second part, which is all of the numbers are the numbers that come before. Then we'll put plus whatever our common difference is. That would obviously be a minus if it was a subtraction problem. So we have first term, then we have plus our common difference. That's our recursive formula for an arithmetic sequence. So whatever that number is that we add each time just gets put right there, which we did the other day. There's nothing new there. It just happens to always be the common difference for arithmetic sequences that goes right there. And your explicit formula for an arithmetic sequence is the first term plus the common difference times n minus 1. So our explicit formula is the first term plus the common difference times n minus 1. And the reason that that's the case is, say I had the following sequence here. 1, 3, 5, 7, 9, ... If I wanted to find the fifth term of the sequence, I know I have it listed. If I wanted to find this and I wanted an equation, let's see if this equation works out, and let's see why. I start with 1, and then I'm adding 2 how many times? Plus 2, plus 2, plus 2, plus 2, right? How many times did we add 2 to get to 9? 4 times, right? But I'm trying to find the fifth term. So I don't need to add 2 5 times because I already had a beginning number. So I start with 1, and then I'm going to add 2 4 times to get to my fifth term. That's what this equation is saying. I get my first term, and then I'm going to do my common difference, and this is how many times I'm going to add it, which is always 1 less than the term number I want. So if I wanted like the 50th term and I was going by 2s, I would have to add 2 49 times. Because you don't want to add it 50 times, because that would put you at the 51st number because you already have your first term. Does that kind of make sense why we have n minus 1 instead of n? If I added 2 5 times, I would be at the 6th number. So that's our explicit formula. If I wanted to plug it in from here, this would be a sub n. The first term was 1. Our common difference was 2. And that's my formula. So this is first term and your common difference. Are we ready to try some of the arithmetic sequences, putting them in the formula? Okay. So the first one is 17, 13, 9, 5. Is there a common change in between all these numbers? Are they adding or subtracting the same each time? Yeah, we're going down 4 each time. So minus 4, minus 4, minus 4. So my common difference is 4, negative 4, sorry. So it asks me if it's arithmetic. It is. The common difference is negative 4. I need to do the explicit formula, and then I'll find this 52nd term. So here is our thing we're going to plug in. We only plug in the first term and the difference. What was our first term in our formula?
17.
What did we? 17. Okay. So our explicit formula is 17 minus, because it was a minus instead of a plus, minus 4 times n minus 1. That's the explicit formula. And now if I want the 52nd term, all I do is plug in 52 in for n. So I have my formula. I can find any term number I want. You just put that in the calculator. It's going to be some kind of negative number, right? Because it's going decreasing by a lot. And I got 187. So this is the 52nd term. There's our explicit formula. Our common difference was negative 4. Do we need to do another one, or you think you're okay with the first one? You want to try one more? Okay. All right, so on number 2, are we adding the same each time?
Where did you get the 52 from?
They asked me in the question to find the 52nd term.
Okay, thank you.
Yeah, they're going to tell you what term they want you to find. So we're adding 10 each time. So yes, it's arithmetic because we add the same each time. And our common difference is 10. So we're going to write our formula. What's our first term? 20, good. Plus 10 times n minus 1. Now we'll find the 52nd term. We're just going to plug in 52 for n. That's 530. You may see the explicit formula like simplified all the way out, where you distribute your 10 and then you could combine like terms. You could see it like that. I think I'm going to leave it in this form though. The times 10 might be on the end on CUDA. I think they do that. 20 plus n minus 1, and then they put a times 10 at the end, but it's the same thing. Questions on writing the explicit formula with an arithmetic sequence? Can you plug in first term and common difference into that formula? Give me a heads up if you can. got 2 heads up, so nobody else can. Not heads up. A shake of the nod. A nod, a thumbs up, a something. Heads up, thumbs up. Now we'll play 7-Up. Did you play that in elementary school ever? On a rainy day when you had to stay inside? Okay. All right, we're still on arithmetic. We're going to find recursive formulas. These are the ones that are a little more straightforward. What are we adding each time on number 33? 8, good. So our common difference is 8. So we'll write our recursive formula. I need 2 parts. First term, and then I'm going to put the part that has the change in it, which I already know my change is plus 8. What was our first term? 38. And that's it. So our first term is 38. Our second part, all the terms after are the terms that came before plus 8. Is number 4 arithmetic? Are you adding or subtracting the same each time? Looks like we're subtracting 3, right? These are all minus 3. So our common difference is minus 3. So you guys go ahead and write and fill out your recursive formula. So we always have this part. So go ahead and fill out what needs to go in the first blank and the second blank. All right, when you got it, go ahead and push the raise hand button. Good, good. Okay, go ahead and type your 2 numbers that go in these blanks in the chat, please. Make sure you put the one that's on the top first. Which one comes first and which one comes second? Good. Our first term was negative 29. And all the terms after that, you just subtract 3. So recap for arithmetic, you add the same each time. Arithmetic add, they both start with the letter A. That helps me remember that. Arithmetic add or subtract, but you know, add and subtract go together. Here's our recursive formula. First term, we put our common difference there. Explicit, first term plus the common difference times n minus 1. And we plug in first term and our common difference. Questions on arithmetic sequences? That's the first half of your homework. You good? You can write those equations, plug the numbers in. All right. The next ones are geometric. If we did adding and subtracting for arithmetic, what do you think geometric is going to be? Multiply. Yeah, multiplying is what we're going to do for geometric sequences. So we multiply by the same number each time. Our recursive sequences set up just like we had before. First term. Oh, I didn't tell you what the common term is. We don't say common difference because it's not a subtracting thing. Since it's multiplying, we're going to call it a ratio. So it's a common ratio. and we use the letter R for ratio. So your recursive sequence is what we did last time. If you're multiplying by the same number each time, you're just going to put times whatever you're multiplying by. For recursive, and the explicit formula is very similar to the one for arithmetic, but instead of doing adding, we're doing multiplying instead. So our explicit formula is the first term, oops, that's an N, I need a 1 there, times the ratio, and the ratio is going to be multiplied a certain number of times. How many times do you think we're going to multiply it to get to whatever term we want? What did we add? I'll go back in a second. We added n minus 1 times, right? To get to where we wanted. Same thing with multiplying. We're going to multiply n minus 1 times. But since it's multiplying something, that's going to show up as an exponent. Like if I wanted to multiply something 3 times, it would be that number to the third. If I wanted to multiply it 4 times, it'd be that number to the fourth. Or n minus 1 is in the power. So if I had 3, 6, 12, 24, is that a geometric sequence? Are we multiplying by the same number each time? Yep, we're multiplying by 2, right? And we start with the number 3. So our formula, let's start with the number 3. We're multiplying by 2, the n minus 1. First term, ratio. Ratio just means what you multiply each time. So on your test, you will be able to write this down. I'll have this part and the part from arithmetic sequences, like when you can write stuff down at the beginning of your test, so you can use that. All right, let's check out these last couple problems. On number 5, are we multiplying by the same number each time? How do you get from 2 to 6? That's a times 3. This is times 3. This is times 3. Okay, good. Our common ratio is 3. They tell us to find the 8th term. We can't do that until we have our formula, right? I guess you could go ahead and do times 3 until you got there, but let's go ahead and write our formula. This is what we're going to plug it into. Y'all go ahead and plug in where you think the numbers need to go, and we'll double check and make sure it's right. Go ahead and give that a shot. What needs to go in the a sub 1? What needs to go in the r? Shayla, you have, oh, you got it. Good. When you think you have it, go ahead and type that in the chat. You don't have to put the a in part, but just put this part in the chat. What's going to go after the equal sign? Yeah, our numbers are going to be 2 and 3. So 2 times 3 raised to the n minus 1. Good job, guys. All right, on 6, are we multiplying by the same thing every time? I know there's a 5 in there, but it goes positive, negative, positive, negative. So what kind of 5 do I need? A negative 5, right? It's not just times a positive 5. It's going to be times negative 5. Times negative 5. So our ratio is negative 5. So let's go ahead and write our, oh, I forgot to find the 8th term. Dadgummit, on number 5. What a tragedy. You just do the 8 minus 1 power. That's what that one is. So 6, we have negative 5 for our ratio. So our formula is going to be, what is our first term on number 6? 1, negative 5 to the n minus 1. So if you are looking for this as a multiple choice option, they might not have the 1 written, right? Because 1 times something's not going to change it. So it's probably not going to be there if you were picking that from a multiple choice. It would just say negative 5 to the n minus 1. So if you don't see a number in the front of your parentheses, there's a good chance that, well, not a good chance, the first term is going to be 1. And to get our 8th term, we just plug in 8, right? We're going to skip down and do 9 and 10 first, and we'll come back and do 7 and 8. 9 and 10 are just recursive. Actually, we'll just do one of them. We don't need to do both recursives. Then we'll do these two. So on number 9, it says find the common ratio, recursive formula, and 3 terms in the sequence after the last one given. So do we see a common ratio right off the bat for number 9? What are we multiplying by? Negative 5, yeah. So our ratio is negative 5. Recursive formula has how many parts that we have to write? How many lines for the recursive ones? We have to have 2 lines. We have to have first term written first on one line. Then the other one needs to be where we tell what happens next. So the first term was 4. The other terms are the terms that came before times 5. Not 5. It was negative 5, wasn't it? There you go. Times negative 5. Could y'all find the next 3 terms in this sequence without a problem? We good on that? We don't have to do that? Times negative 5 times negative 5? Okay. So recursive is fine? Seven and 8, they give you the formula and they want you to write the first 5 terms. So we can plug in 1, 2, 3, 4, 5 in there if we want to. But is this just a geometric sequence formula? A first term, a common ratio, and n minus 1. Isn't that just your thing? Can you identify what the first term is going to be if you have this formula? What's your first term going to be? 2. This is your first term, right? What is your ratio that you're multiplying by each time? Negative 3. That's your R. So instead of, I wrote -3 instead of R. So instead of having to plug in, you know how yesterday that, or whenever it was that you did it, you had to plug in a 1 and evaluate it in the calculator, and then do a 2, and then do a 3, and then do a 4, and then do a 5. Well, now we know where it starts, and we know what to multiply each time. So do you think that would be easier than having to plug the numbers in? Than having to write all that out? Yeah. Our first term is 2. Then we're doing times -3 each time. So that's -6, 18, I don't know, 54, -54. And then 162. So if you can identify where you start and what you multiply by each time, you don't have to plug the number in for the n for the geometric sequences. Thumbs up on 7 that you can see that's where you start, that's what you multiply by. Okay. On number 8, what would be your starting term? -3, that's our a sub 1. What are we going to multiply by each time? We're going to multiply by 3 each time. So we start with -3, then we do times 3. Times 3. Questions on these two, finding the sequence if you have the formula? It's going backwards. Okay. Again, still, if you get stuck, you can plug a 1 in and evaluate it in the calculator, plug in a 2, 3, 4, 5. If you like to do that, that's okay as well.